Hello students, in this class we are going to see the experiment number 9, develop a menu driven program to fill up the polygon using scanline algorithm. So in short we can call scanline filling. I am going to explain the scanline filling algorithm. You know the textbook, Hahn and Baker, you can refer. Edward Angel, the second textbook, have all the program, please refer the book. What is this polygon fill? You have to draw a polygon and fill a color. Okay, but there is one more condition. See the question. Develop a menu. You have to create a menu. From the menu you have to apply the logic. Here I have attached the output. So I have created the output window. First the output window will be blank. You should be able to create a menu. This menu is coming after clicking right button. So now you can see how to create a menu. You know the command glut create menu will create a menu. The menu name is fill menu. So this menu name is fill menu. Inside this menu item you can create, right? So we have only one menu entry, fill polygon menu entry. So that is added here. Glut add menu entry, fill polygon, and index number is 1. So if you add one more entry, that is index number 2, add one more, that is 3. Like that you can give. So we have only one option here. So fill polygon will have 1. Now that is attached to our right button. So whenever you click right button here, this menu will pop up. Okay. So you click a right button here, this menu will pop up and you will select on this, you will press this menu entry fill polygon. After pressing fill polygon, 1 should be passed, right? It means user has selected 1. So based on the option we have to write the code, and here to receive the options from user, this code is used. Void fill menu. So you know the menu fill menu, void fill menu, int option. These are options. So you have given only 1. You may have 1, 2, 3. So depending on the value, that option value will pass to this argument. It will come here. Because we have only one option, only filling option. If option equal to 1, I am setting a variable flag menu, a fill flag equal to 1. So based on this fill flag equal to 1, you can fill by calling a display function. So we are calling a display function for whenever you are pressing 1 for the value of 1. I hope you understand the menu creation. Let me summarize. First we are creating a menu called fill menu. Only one option we have, that is fill polygon option 1. So whenever user is selecting, right click this menu and selecting this option 1. So 1 will be passed to this function. Based on this we are setting a variable 1 and we are calling the display function. This is attached to right button. Let us see the basics. So this is a polygon here. So we have to create this polygon and we have to fill the color. Here we have created a polygon and we have filled yellow color. Now what is the coordinate for this polygon? That is initialized here, x1, y1, x2, y2, x3, y3, x4, y4. So here you can see the 4 value. This is 200, 200, this is 100, 300, this is 200, 400 and this is 300, 300. You can see 4 coordinates. And this polygon should be drawn. So GL color RGB. So a blue color polygon, only outline polygon, blue color polygon will be drawn. GL color, blue color I have set, GL begin, GL end, GL line loop. This line loop will be drawn from x1, y1 to x2, y2, x3, y3, x4, y4. All these values are connected. So one polygon is drawn using this line. Already we have set the fill flag equal to 1 based on the option. So if the option is called, then we are calling the scan fill algorithm. So we have to fill up this polygon. To fill up this polygon, we are passing all the 4 coordinates x1, y1, x2, y2, x3, y3, x4, y4. Now you see how we are going to fill. So we are calling this polygon scan fill x1, y1 to x4, y4. This polygon scan fill. Okay, we'll see what are the initialization we have done. The first 2 lines are initializing LE, that is left edge array. So you can see this polygon, you can divide this polygon into left side and right side, correct? So left side edges are declared as LE, and right side edges are declared as RE. So we are setting a array of size 500. It is a user defined variable. You can understand the coordinates are below 500. You see here it starts from 200, 300, 400 and again 300. We are not drawing a polygon bigger than 500, so this array is declared with 500. So it depends on your coordinate, you can change the value. So these lines are declaring two array, left edge array and right edge array. Size of 500, you can see down. I have drawn this array in a word just to understand. So we have LE array, RE array. There is a for loop here. This for loop will run 500 times 0 to 499, and it is initializing some value in LE array and RE array. Can you see the value? In LE array 500 is filled. So here is the LE array. So LE array, these are index 0 to 499 we have, and each index is having a value 500. Okay, and there is a right edge array declared, and the index are from 0 to 499 and values are filled 0. You please remember both the arrays are not having same value. Left edge array is filled with 500, value 500, and the right edge array is filled with 0. So now you can understand we have drawn the polygon and we are going to fill, we have just initialized. Now in this polygon, how many edges are there? You can see here 4 edges are there. Left side 2 edges and right side 2 edges. Correct? So we have to deduct these edges. What do you mean by deduct? What is the point on these edges? This is point 1, point 2, point 3, point 4, like that. All the points of left edges must be deducted. Same time right edges should be deducted. By deducting, what we are going to do? So from left edge to right edge, you can see 4 edges are there. From left edges to right edges, we will fill up this line. Only this line coordinate will change the color. That is the logic of this program. So here 4 edges are there. So we should call 4 edge deduct function, and we are passing the parameter. First edge you see this is x1 y1 to x2 y2. So that values are passed. Like that all 4 vertices are passed along with same array. LE array, RE array. Same array only passed along with all edges. Now we'll see the edge deduct function. Now here we have 4 edges. We have to deduct these edges. So we'll see the function void edge deduct. This is the input variable x1, and we all x1 y1 x2 y2. This is the pointer array. So you are changing the array value here by using your code. Then you come out of the program. The value of LE and RE will not be changed. That's why it is a pointer array. Pointer LE, pointer RE. Now here you can see some declaration part we have. Mx means to find the slope. Some temporary variable we have x and temp. There is some part of code we have. What is the use of this code? You can understand these edges. Can you tell me the slope of this edge? Is it positive or negative? So this is a negative slope and this is positive slope, and here also you see this is a negative slope and this is the positive slope. So this is to swap the negative slope, and we swap the edges to not to get a negative slope. So you can see the comment here, we swap so we don't get a negative slope. Okay, we'll see the first edges. Now as per our code, 4 edge will take first edge now, x1 y1 x2 y2. Okay, so that is this one, x1 y1 to x2 y2. Correct? Can you apply the value here? Y2 minus y1 is less than 0. What is y2? This is x1 y1, this is x2 y2. So 300 minus 200. So 300 minus 200, is it less than 0? Is it less than 0? 300 minus 200 is 100. So 100 is less than 0. Condition is false. So this part will not run. Okay, this part will not run. Now we'll directly go here. Same value, is it not equal to 0? Yes, it is not equal to 0. So you can find the slope mx equal to, can you apply the value? This value, can you apply the value? X2 minus x1. This is x1, y1, x2, y2. 100 minus 200. So here 100 minus 200 divided by y2. 300 minus 200. That is also 100. So minus 100 by 100, it is minus 1. Else part will not run. So slope is calculated here for this edges. Now we are performing on LE1, left edge 1. Okay. So up to this we have executed. The value will be minus 1. Now you see this for loop. This for loop is running from y1 to y2. So for these edges, y1 is 200, y2 is 300. So this for loop will run from 200 to 300. I have shown the array here. So you know the left edge array and right edge array. So we are taking this left edge array. In this left edge array, this for loop is running from 200. I have given the index here 200, from 200 to 300 because y2 is 300 here. So up to 300 it will run, and when the next time it will run from 300 to 400. So only these two, LE1 and LE2 only will be running here. So the remaining value will not be executed. Okay. So we'll see the inside for conditions of for loop. If x is less than LE of I, what is LE of I? That is left edge of I. Left edge of I is 0, right? Not 0, y1. It is starting from y1 200. So LE of 200 already we have initialized 500, correct? So this value is 500. You can see here 500. What is our x value? Here we have initialized x equal to x1. So what is x1? 200. Condition is true or false? 200 is less than 500. Condition is true. So we are assigning that value in this location LE of I. So in this location we have to assign the value. This 500 should be replaced to 200. I'll show you. So here you can see that value are assigned here. Next condition, you see x is greater than RE of 0. What is x value? You know it is 200. RE of I, you see here RE of I. RE of 200 is 200. So x 200 is greater than 200, but it is equal to 200. Equal to means true, but greater than 200 is false. So this condition false, it does not work. X equal to x plus mx. You are just initially incrementing your mx. So what is our mx? Minus 1, right? So minus 1. Again you add another minus 1, it becomes minus 2, correct? So this for loop will keep on running from y1 to y2, means 200 to 300. You can see from 200 to 300. From this is the index value 200 to 300. First we gave 200, correct? This value assigned 200. After applying mx, one value is reduced to 199, 198. So like that here you can see 200, 199, 198, 197, 196, like that all the x values are assigned in this location. You understand now? So after assigning from 200 to 300, it comes out of the program. Next what will happen? We'll call the next edge direct. So these edges are called. These edges means which values are passed? 100, 300 to 200, 400. Okay, we'll see the example now. Here in this condition, this statements will be executed. This is LE2. Y2 minus Y1, which is Y2, and in this case you are passing the value, so all the variables are renamed x1 y1 x2 y2. So here in this case this is becoming x1 y1 and x2 y2, right? So you subtract now. 400 minus 300 is what? 100. 100. L y2 minus y1, 400 minus 300 is 100. Condition is uh, condition is false. There is a value here. Okay, you leave this. Same logic will be executed. LE2 will be calculated from 301 to 400. Can you guess why it is 301 to 400? Because starting from 300, 301, 302, 304, like that till 400 this will run. It will calculate the value. You can understand 1. So the value first is 100, then 1, 2, 3. Can you guess why it is 1, 2, 3? It is not minus 1, minus 2, minus 3. When you calculate mx for this side slope, it is positive 1. So first value added, added, added. You can understand the previous one, it is reduced 200 199. So because this is this side, slope is minus and here slope is plus, correct? Now this way LE array will be calculated. So all the values of this edge and this edge is calculated. Now this part, actually this part is not running for left edges, it is running only for right side edges. Now we'll see the right side edges, third edge detect will be called, correct? This edge detect. Now we'll see the third edge. That function will pass these four value. Which four value? You must understand it is 200 400 to 300 300. This swapping has to be done. Then only the uh, value can be uh, written in an ascending order. Okay, you see the value, we have initialized the value. Can you see the third edge here? Third edge 200 400 to 300 300, right? See, this is ulta, this y case 400 to 300, this is a reverse order, but we should make it to 300 to 400. Same array only. I'll go back here. The same edge only we are detecting. The deduction is from bottom to top is easy based on our array calculation. If you start deducting from here top to bottom, means the values are in the descending order, right? From 400 again the 399th value. Instead of calculating like that, you see the array here RE2. RE2 is starting from 301 to 400. Otherwise, the logic should be starting from here. The value should be filled here, 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 like that. So this swapping will happen only for right side edges. So here, now the values are passed, right side edges, value based on the right side edges, the values are swapped. Instead of 200, 400, it starts from 300, 300 to 200, 400. So the y value will start from 300 to 400. Here you can see the y values are from 300 to 400 RE2 value. This is the initialized value. The calculated value will be done based on this logic. I'll give a brief introduction about how the values are calculating. The same manner, the for loop will run from y1 to y2. Here, can you guess what is y1 to y2? That is 300 to 400. So after executing this part will be running 300 to 400. Now 301, same condition will check. What is x here? X is 300 here. Is it less than of x of LE of I? What is LE of I? This part will not run for this value. Already values are filled, right? Some values, so the calculated value, I'll show you the next slide. Calculated values are stored in LEF array. So this will not be running, and this case only will run. X is greater than REF. Values are what? Initially 0, right? All initially values are 0, so values are filled. Here condition is true, so REX X300 is assigned to REFI, REF 300, 300 301. So from 300 the values are filled. 300 here negative slope 299 298 200. So this is based on the negative slope, all the values are filled. Same manner the last edge, this is the last edge, it will be filling from 200 to 300. You can see here 200 to 300, 200 to 300. What is the first value? Swapping will be done before starting. So based on this swapping, it starts from 200 to 300. The first values are calculated here, that is applied here. Then the next value, slope is positive, 201, 202, 203, like that, one by one all the values are filled. So now after executing this, what happened? You have calculated each and every value of all the edges, LE1, LE2, RE1, RE2. Now we have to fill up this, correct? We'll see the next. Now we are going to fill yellow color inside. Okay, so y value from 0 to 500. Actually we are starting from 0 to 500 because the maximum value we have initialized like that, but values are falling only between 200 to this range only, 400 only, right? So only on those side we have calculated the new value and stored in the array. So this loop, even though it runs from 0 to the end, 0 to end, the logic will be applied only on this side. Now one more inner for loop, you can see LE of y is less than RE of y. What is LE and RE? These are array. So we have LE array this side, left edge, and RE array this side. So I'll take one sample case here. From this edge to this edge, we'll scan and we'll just fill up the yellow color on this line. That is scan line algorithm. So you can see the logic here. From LE of Y to RE of Y, we are drawing the pixel. The draw pixel is here. You can see the draw pixel. The pixel is drawn with yellow color. This yellow color is set here. So once you draw the line here, one yellow color line will come. Actually, it starts from here to here. Yellow, 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 like that. Full colors are filled. Fully yellow color. I hope you understand this polygon fill option. Now, can you name this logic is used in MS Paint? Like this fill color option we have used in MS Paint. Have you seen the tool? Which tool it is? Yes, you can see in MS Paint, Microsoft Paint, we have used that fill color option, this bucket. Just click on this bucket, you select a color, you fill any polygon or circle. So this logic is running in the background. Thank you.